manufacturing, it's printing you have seen. About or around, I think, 2000 cane they print through that machine in 1 minute. In 1 minute, 2000 canes. A man cannot print one cane even in 1 minute, right? And see the accuracy. This was the speed. See the accuracy. They have high speed camera there. If you get any problem in single cane, some small defect in print, if that camera will find, in that speed, that particular cane will be rejected. In that speed. See the accuracy. So in manual operation, it was not possible. Obviously, now also it is not possible. Manual operation will not handle all these time taking and accuracy thing will not be covered there. Very first, one automatic system came. You can say the controller. It was relay logic controller. You should know about that also. Very first, we had one automatic system that was a relay logic controller placed. Relay logic controller. Relay logic controller, what was it? Nowadays also, if you're from electrical, you have seen push button and motor. In lab, you have seen, you will have green and red push button. Have you seen? From any branch, you have seen one motor, one pump, push buttons. Have you ever thought, push button has property, you press the push button, you will get signal. But as you leave the push button is off. Means you are not getting signal, but motor is continue on. How? There is no controller there. There is no microcontroller there. It is relay logic control there. Relay logic control. We arrange some electrical circuit there. We make some electrical circuit using electrical and electronic devices. So very first, one automatic system came. It was relay logic controller. In relay logic controller, what we had a very large, complicated electrical electronic circuit, complicated. What you have to do, what would be the sequence? That sequence was made through the circuit. And obviously it was so difficult and so complicated. It was that large, you could go inside that. It was that large. But it was automatic. It was automatic. But we had few drawback. Obviously, we will have drawback in that. Very first drawback was, once the system was shut down, you imagine from where you will start finding the problem in that circuit where you can go inside it. So the problem was, it was complicated. It was not possible sometimes to find out the problem in that circuit. What we had in that circuit, we had wires. We had relay, we had contactor, initially we had vacuum tubes also. And do you know, nowadays also we use vacuum tube, where we have high temperature, like in steel plant you go. For furnace, they use vacuum tube nowadays also. For that is for information only. So initially we had many electrical electronic circuit devices there in that circuit, in relay logic. We had their hardware timer also. Nowadays you learn timer in software, right? No, soft timer, soft counter. Initially we had hardware timer, hardware counter. Nowadays also you can purchase all these things. So it was very difficult to find out the problem in that complicated circuit in relay logic. Second problem was, it was made for some dedicated application. You could not make change in that. So for one application, once you decide what is the application, what is the sequence, for that it would be designed. And further, if you will say that I want to add something more or I want to remove something, it was difficult. So it was applicable for dedicated application. That was also a problem. Modification was a bit difficult. We could not make modification in that circuit easily. Monitor mode we did not have, obviously. So relay logic controller, you understand? Nowadays also, if you see some press machine, some old, not new, or some mechanical system, it will have relay logic there also. But now they are replacing with PLC. You know. Then one new controller came, everyone knows about that. Microcontroller, right? No, microcontroller, everyone is knowing about that. Microcontroller is very good. Why? Because it is very compact in size, very cheap in cost. Right now in 200, 500, you can purchase one microcontroller. Anyone can purchase that. Even one PLC of this size will, branded one, not brand, non-branded I'm not talking about, branded PLC, Mitsubishi, LML, Siemens. Of this size, you will have to spend 30,000, 40,000. But a microcontroller in 400 you can purchase. So it is very good. The best part of this controller is you can program it. So if you are able to program any controller, that is the best part. As per your requirement, as per your need, you can make modification anytime. But obviously we faced some limitation. I'm not talking about the drawback. There is no drawback. What is the drawback? It was the first automatic controller right now, electronic programmable controller, microcontroller. So it has no drawback. We had some limitation in that. That's why only PLC has come. I'm not saying that PLC is good, microcontroller is not good. Microcontroller is very good. But if we talk about today's industrial environment and requirement, we have few limitation in microcontroller. That's why we work on PLC. Let us talk about few points, because this is the question of interview also. They will ask you, why PLC, why not microcontroller, right? When you will go through internet, you search that in Google, you will find many points there. And I have seen always it would be some fight there. You see some conversation that they will fight, PLC people and microcontroller people. And in academics sometimes, nowadays I don't say anything wrong about microcontroller, because sometimes I also face the situation. In academics we get some problem. People say that, no, why you are promoting PLC? I'm not promoting PLC, I'm saying the limitation of microcontroller. But I will talk about the practical limitation, what we have practical limitation in microcontroller, why we are using PLC there. Very first limitation in industry we consider, nowadays also I work in industry, I have come from industry. And since 9 years I have been working in automation. So, very first limitation we consider its programming language based on C, assembly language, machine language. It is okay, we will learn that. Engineer can learn anything. But the problem is everyone is not knowing about this language in industry. You meet many people there, they all are not known of C, C++. When I was in college, I was very good in that because it was my field of interest, logic development. But now I just remember printf, scanf kind of thing, nothing else. I cannot make one program for microcontroller because I am not in touch with that. Even if you have learned microcontroller programming in college, you can make project, but are you sure that you will be able to make program for a machine? You have some limited, means you have learned some limited thing in college. If you have to learn everything about microcontroller, spend 4 months, 5 months, 6 months, then you will be able to do that. You have many things there for industrial system. So very first limitation we consider its programming language. Let it be, we will learn that. And nowadays you go for mechatronics, mechanical department, they have added automation. They have to also learn all these things, microcontroller, PLC, SCADA, they have to also learn. And mechanical people are not in touch with electronic and electrical circuits, so they might have some problem in logic development. Second thing, I will just come to the practical point. Practically, we face problem with microcontroller in monitor mode. In troubleshooting, we face problem. Why? Nowadays, we have monitor mode in microcontroller also. Nowadays, not in conventional. In Arduino, you have monitor mode and all. And in some microcontrollers also, we have some monitor mode. But I have seen that its monitor mode is, it will show you some sentence like this is on, this is off. It will show you the status. But it would not show you the flow. What is the flow? Why the supply is not reaching? Which input is on? Which output is on? Because of which input the output is not working? So practically, if we work on microcontroller and we troubleshoot the machine, we have problem with monitor mode. This is the main problem a maintenance engineer face. So personally, I think its limitation is its monitor mode. It is a big limitation for industry. For college, we become very happy that okay, we can monitor everything easily. We can download the program in Arduino. Arduino is kind of PLC. But its monitor mode is not that comfortable to troubleshoot any machine. Next, you see, you won't believe, but this is the fact. Once you install one PLC with proper wire, proper power supply and earth, PLC will never get out of order. I will give you some reasons also. PLC will never get out of order if you install that in one panel with proper power supply and proper protection. Why will it not go to, it will not go out of order? Because in its architecture, in its manufacturing, I think you understand, one PLC will have input terminals on this, right? No, one PLC will have input terminals on this, will have output terminals on this, will have processor inside, CPU. Obviously, if any sensor is on, the signal will go to the input terminal. From input terminal, that signal will go to the processor, to the CPU. And when CPU will generate some signal for output, that signal will go from CPU to the output terminal. The thing is, we have isolation. What type of isolation? We do not have physical connection, physical wiring connection we do not have between input and CPU and between CPU and output. We do not have wire connection in that. So if you provide any wrong supply also to input output, it will not reach to the CPU and CPU will never get out of order. But how the supply will reach to the CPU? Optocoupler. You have heard about that, light emitting diode. So what we have optocoupler in between input and CPU, between CPU and output. So if any signal will be sent to input terminal, that optocoupler is on, light will be emitted to the CPU and CPU will get signal through light. So if you provide some wrong connection there, that light won't harm the CPU. This is one isolation. Another thing is, on each input-output terminal, you have one protection. I will talk you about that further. So you have many protections in that. You just meet some industrial people who have been working since 40, 50 years in industry. Many people come from oil and gas industry to our institute in Pune. They say, sir, for 50 years. Outdated PLCs have been working. Manufacturing has been stopped for that model. There is no support for that model. But that outdated PLCs have been working without any problem. Because CPU can never get any problem. It has isolation. Okay. So we have limitation of monitor mode and some other things also that I will talk further. Let me directly come to the interesting part because I have obviously many boring topics with me. And in college also you have seen the boring topics will be so important, isn't it? You need to concentrate on that. So like that, I have also many boring topics. Further, I will cover that, but I will cover that, no problem. Programming is the best part and the interesting part. I will directly come to that gradually. So we have some limitations in microcontroller. That's why PLC has been invented and we have been using. And nowadays, after PLC, DCS have been in market right now. You know, you have heard about DCS, distributed control system. After PLC, now DCS also we have to use in industry, but don't be worried. If you know about PLC, you can work on DCS because we have the same concept there. I will talk about that further. Let us have some talk about PLC. Programmable logic controller. Many definitions you will have in internet, in some book also you can find some definitions. Practically, PLC is an electronic digital device. I will force the digital one. You will have to understand it, digital term. PLC is an electronic digital device. It is not analog device. It means only digital input output we can connect to PLC. Be very clear about it. To the PLC input output terminals, you can only connect digital inputs and digital outputs. Means the inputs outputs which are getting on or off, just on and off. You cannot connect one analog input or analog output to PLC input output terminal directly. Like temperature sensor, pressure sensor, level, flow. These transmitters we cannot connect to PLC directly. For that we learn ADC, DAC, right? No, ADC, DAC, analog to digital converter and digital to analog converter. That we connect to PLC, that also I will show you further. And to ADC we connect that analog input. So PLC is an electronic digital device which takes input, generates output according to the logic developed, PLC has 6 programming languages. It has 6 programming languages. Common language, easy language is ladder diagram, LD we call it, LD. Ladder diagram is very easy to learn by any engineer. Mechanical, electrical, electronic, anyone can learn this. In industry, ladder diagram is appreciated by people who are working there, because in ladder diagram it is very easy to troubleshoot the system. It is very easy to make one new project. Further we will learn this also. Once you learn ladder diagram, other languages also you can learn very easily. It has option to just convert your language, one language to another language. So ladder diagram, it is used by industrial people. It is very easy to learn. It is similar to basic electrical diagram. Now, mechanical people, you don't think that it is the part of electrical. No. Basic electrical diagram, and let me make you remember you are an engineer. So it doesn't matter you are from electrical or from mechanical or electronics. Everyone knows about line, neutral, and earth. Everyone is knowing about one switch. Everyone is knowing about lamp, fan, motor, single phase. So it is similar to basic electrical diagram, so it is very easy to learn. Then it has very easy communication option. In fraction of second, you can download your program. Anytime you can upload your program. Machine is running. In run mode also you can take the program. It has online edit. Online edit means machine is working, machine is running. And in running mode also some modification you can make. But in another controllers, once you download your program, once you modify your program, PLC will go in stop mode. Means controller will go in stop mode. But in its software you have option online edit. In online edit, in run mode also you can write your program. I will show you that practically also further. It has a redundancy. Redundant system means a standby system. And redundant system only, now we have in DCS. Redundant system is only DCS nowadays. I will explain it further. PLC programming, let us come to that. PLC programming, as I told you, is very similar to basic electrical diagram. If I directly start giving you programs and I will say make program for this system, might be you will get confused. So I follow one way, I follow some steps. If you follow that step, it's my guarantee today only you will become one programmer, and in half an hour you will start making program without my help. So let us follow some steps, let us follow the way. Often for students, for faculty member and for working engineers also, I start with the same. I start PLC programming with 3 or 4 basic electrical diagram. We will have some talk about that diagram and we will start PLC programming. If you understand 3-4 diagrams, it will help you to make ladder diagram programming very easily, believe me. So you people have to answer few questions and have to draw some diagrams. I will write that on board and you have to follow that, right? Okay. Our electrical work will start from any electrical work will start from the socket. I'm talking about single phase. So I have few questions. You answer that. It is not the topic of electrical only. It is for all engineers. You have seen this, right? No, you have seen this anywhere, in your home also, at your home also. Answer me, what is this upper terminal for? It is for earth. Everyone is knowing that. Very good. And you know, in industry, there is one question also. This training should be interview-oriented also. We have designed our syllabus according to the interview also. A few days before, I got some message from MNIT students only. They had interview, Tata Motors, I think, had come. Many people messaged me that it was very useful training for us because they asked question about automation and many topics they asked about automation. So we have designed our syllabus according to that. So there is one question for interview, and this question is asked from experienced engineers also. Why this terminal is bigger than these two rest terminal, right? No, the question is why this earth terminal is bigger than these two terminals. You decide that. I have not to be in that. I will proceed. Now you answer me, this is earth, left terminal. What is this for? You are engineer. So you must know the standard, universal standard. What is this left terminal for? You can't say anything, line or neutral. Engineer, huh? You believe that you are engineer. So what is this left terminal? It is for line or neutral. Okay, always remember from now, universally, and you purchase one new socket, it would be written on that. Right side is always line and left side is neutral. It is a standard. We can connect any, but it is the standard we must follow. So right side, it is line, always, it is line. You purchase one new socket, you will find on that. It is written on that. Okay. You have seen some switches, normal switch, toggle switch, that we use at our home in college also. Behind any switch, you will have two terminals, and this is related to your PLC programming, so please learn this. Behind any switch, push button or toggle switch, you will have two terminals, right? And you have seen single phase devices. Don't be confused about single phase and three phase. At our home, all appliances are single phase. We do not use three phase device at our home. Once I had asked this question in some engineering college, I won't take the name. I asked, do you have any three phase device? Some students told that, yes, we have. I asked, which device you have? Appliance at your home, three phase. He told, I have a very large refrigerator at my home that is three phase. It doesn't matter what is the size of the appliance at your home. It is single phase. And single phase means line neutral, line neutral, line and neutral only. So let it be any single phase device. Consider one lamp, motor, fan, pump, anything. It will have two terminals, right? So it will have only two terminals. Earth we ignore now, two terminals. Your task is draw the same 3-4 diagrams we shall make and we'll start PLC programming. So you have two terminals line neutral, two terminals on switch and two terminals on lamp. You have to wire these three devices. Make it fast so that we can start PLC programming. Draw the same and wire these three. By operating switch, we have to get the lamp on and off, right? So wire these three. Everyone, please. And we will start PLC programming after that. Wire it, everyone, and have discussion with each other, please. It is line neutral, two terminals of the socket. Huh? Line neutral, two terminal on switch and two terminals on lamp. You have to wire these three so that we can get the lamp on and off. Okay? Line. This is the socket. Line. Okay. Great. Very nice. Is it the same? Check that. Why this? Not like this. This is the book thing, huh? No bookish diagram. It should be real diagram, huh? Very good. Where is line neutral? Line neutral also you have to add. Line neutral. Okay. And I think we should have one common diagram, right? No? It should not have 2 or 3 types of diagram. Did you wire this? Wire this, please. You should have common diagram. But I'm saying I'm getting 2 diagrams here. We will have some talk about that. We should not have different diagrams. We should have all common diagram. Okay, we will have one talk about this. This will help you in making PLC program also. Concentrate. And being an engineer, you should know this. See this. The problem is we are engineer. And being engineer, we are so smart. And we find shortcut also right now. It's our tendency, we find shortcut. So what we have done, 2 terminals, 2 terminals, 2 terminals. The shortcut is just connect 2 terminals and connect 2 terminals. Some people have wired like this. It is not correct. It is not correct. It is wrong actually. Correct? No? It is wrong. Why we should have one talk about this, please. And don't feel hesitation to ask question. Please ask the question also. And this must be clear by everyone. You see this. If you wire like this, what happens? What is a switch? Switch is an interrupt. It is just one interrupt. In any switch, you have this contact. If I say you, do you remember this? You will say yes. Do you remember this? And you understand it also? Because it is in book. We have also studied like that. But if I give you some real system in your hands and will say wire it, you might get confused like this. See what happens. We have contact in any switch. In sensors also we have contact. So what happens? Instead of this, you can do one thing. Take one wire U-shaped, strip both the ends, put that in line neutral and switch on. What will happen? Short circuit. So you are doing the same. If you wire line and neutral both to the switch, you will make it short circuit. Switch is on, short circuit, right? No? So don't do that. It is not correct. So do not connect your switch to both terminals, to both paths. Now you answer me. From the output, if we have 2 wires and we connect these 2 wires to line and neutral, what will happen? It will be on. It will be on. If I will say switch off, you can break this wire. It is switch off, right? No. I will say switch on. Join this wire. It will be switch on. We have not to break and to join. We have to just use one switch like this. Isn't it? Isn't it? So, from now, always remember, we have to connect all our switches in single paths. We have to connect all our switches in single paths. One question is, if we connect switch in neutral, I'm not connecting that in line. I'm connecting switch to neutral. Are you understanding it? My question is, if I connect, I'm just changing the terminal. You just consider that. It is neutral and it is line. If I connect switch in neutral path, is there any problem? Will this lamp get on and off? It will get on and off. But is there any problem? We should connect our switches in line path always, not in neutral. Why? Why? Any electrical engineer? लीकेज करंट you're right, but लीकेज करंट का केस सर हम लोग अर्थ में उसको अर्थ टर्मिनल के थ्रू हम लोग उसको सॉल्व करेंगे. But the question is, what is the problem if we connect the switch in neutral path? Is there any problem? Is there any problem to lamp? There is one problem, major problem. Do not connect your switch in neutral path. You see what is the problem? Safety is the problem. You see this and try to understand. See the problem. You have connected the switch to neutral path. Lamp is out of order. The lamp is not working. You will change that. What you will do? Switch off, because protection you are following, right? No. Safety first. So you are going to switch off. Okay, you have switched off and you will think, okay, now I have switched off. You will go, will open the lamp. And after opening the lamp, sometimes we play with that. टच करके देखते हैं क्या होता है. उसमें एक नॉब होता है, स्प्रिंग. अच्छा है. So what you will do, you will think switch is off and you will play with the terminals of the holder. And you see line is already there. Line is already there because you have broken neutral path. So you will think that switch is off, no problem, but line is still here. So always connect your switch in line path so that when you switch off it, line path should be terminated. Neutral will not give you shock, but line path will give you shock. So don't do that. And let me remind you one picture. Three Idiots, do you remember? There is one major problem in that starting scene, ragging, spoon, line neutral. You just notice there what Amir Khan has done there. He had just connected that two wires, switch off, and then he used his teeth. You don't believe on the wiring because one man has wired that. If the switch is connected in neutral path and you have switched off and you're using your teeth, there is no way, right? No. So don't believe on the wiring because a man can wire that switch in neutral path also. You will think, okay, switch is off, but still line is there. So always connect the switch in line path, not in neutral path, right? No, from now we all have to remember this. So what we have learned here, we have right side line path, line terminal. This is the standard. Second thing, we have to connect all our switches. Let it be any number of switch. All will be connected in line path, not in neutral path, right? Okay. 3 more diagrams you have to make and we have to start PLC program. Yes, please. Line and neutral, phase and your branch is mechanical. Okay, line and neutral. Actually, this is for getting any output on, you need to provide some charge there, some potential there, right? Line and neutral terminals, actually, there we have those potential. Line terminal, line potential is there, and if you want to run one output, actually output is one resistance. That lamp you can see or motor, that is one resistance. Once line and neutral both will be given, then only it will get on because one loop should be there. One loop should be made there. From, you have heard, charge will flow from line to neutral, positive to negative. So once it will start flowing, then only your lamp or any output will get on. So we have charge, the line is there, but line will not proceed because without of neutral. Line path will not work, a lamp will not get on without neutral because that charge must get the path, that electron must get the path. So what we have line supply here, we have charges there, but it is not flowing now. As you switch on, that will start flowing, will go to lamp, resistance, some charges will be occupied, some loss will be there. Because of that, you will have that on and it will finish the loop and lamp will get on or any output will get on. Okay, fine. Yes, sir. Yeah, I'm coming to that. Actually, yeah, ask me. That I'm saying, you know, how you can check. Okay, I will tell you that also. Once, I think in 2008-9, I was staying in one hostel, but I was working in industry. So I had one tester, you know, no tester. I had one tester in my pocket and accidentally it came to my room also. And once you have one tester in your hand, you will do something. I was doing the same. I just switched on and checked that. Both the terminals. It was glowing. The tester was glowing. It was on.
And simply I switched off. And suddenly I came there and I thought to check again. It was switched off. Switch was off. I checked. Neutral, no supply. Right side, it was supply there. Means the tester was on. If switch is off and tester is getting on, it means the switch is connected to neutral path. Are you getting it? Okay. I'm just coming to earth also because the question has come from earth. And it is important for all branches, so don't worry, we will come to programming also. Why do we use earth? Why do we use ground? What is the reason? Why should it go to earth? Leakage. No, not for safety of devices only, safety of human also. Device, okay, you're correct. But for safety of human, basically we use earth. Okay, let us have some talk about that also. Earth we use for leakage current should go to the earth, right? No, earth we use so that the leakage current, what we have in the body of the appliances, should go to the earth. One question again to everyone, to the engineer. What is this leakage current in any appliance body? Initially I used to think, and I think you also think, that leakage current means the line wire is damaged and is touching the body of the appliance. It is like that. Sometimes we think like that line wire is in the connection of the body of the appliance, like your computer CPU, iron box, microwave oven. Everywhere you have leakage current. But you do not have leakage current in your TV. You see, your computer wire, 3 terminals in that. In that socket, in that wire you will have 3 terminals. 3 terminals means you need earth connection. You use laptop charger, there also 3 terminal. If you don't have earth connection in your house, you touch its USB port, you will get shock there. Laptop. If you have earth connection, you won't get shock. Computer CPU, you purchase one new computer, branded one, and you don't give it earth connection. Take it. So you check that. You have new computer, you check computer CPU. Take one tester and check that. You will get it glow, proper. Means you have proper supply there, which can give you proper shock, right? No? So, what is this leakage current in that? That is the question. In industry also, what is that? You are purchasing one new computer and its CPU is showing you supply in that, leakage supply. I don't think there is any wire touching to the body of the CPU. Purchase one iron box. We call it iron only, right? No? Iron you call? Electric iron. Press, actually. You purchase any brand. If you don't give it supply, this is the most dangerous device you are using at your home. If you get shock from that iron box, you will have to sleep for 3-4 hours. You can't do anything. It will give you proper, and it will give you more shock than other devices. I don't think there is any wire touching to the body of the iron, right? No? What is this leakage supply? Actually, this leakage supply is when you have iron box. You have, inside that iron box, you have coil, high resistance coil. When you have coil, you will have electric field there, magnetic field there, right? No. And because of that field is touching the body of the iron box. You have many electronic devices in the CPU. It has also induction, and you are getting some leakage, means some field you are getting to the body, and that is the leakage supply. So you must have earth so that leakage supply can go to the ground. Means that ground will be better conductor than your body. It will select the better path, right? No? That current will select the better path. So you will be resistive, and that will be better path. That's why Your earth connection must be good. Remember your first year, many years ago. First year is very bad, means very back time, long back. Third year, you are in third year, fourth year means first year is very long back. In that, I remember it was plate earthing and pole earthing. It was for all branches. It was for all branches in first year. Plate earthing and pole earthing. You should have proper depth. You should have brush, plate or, yes, sure, sir. Yeah, sure. You should have brush plate or brush pole. You should have salt in that. You should have charcoal in that. It should be proper earth. But what we do practically, I don't think it is limited to some state. In every state, you go to villages. Behind your house, you will have one, you will just make one well, small well. Will take one iron rod, you will put in that iron rod. And daily evening, you will take water and will pour in that so that you can get good voltage in your house. This is wrong. Sometimes you will go to pour the water and will never return back. So don't do that. That is dangerous. And sometimes at home, construction is going on. After construction, some rod has been left to the pillar. We use that also. We connect our earth wire to that rod, left rod. And in rainy season, sometimes we get shock from the wall. And we don't understand why are we getting that shock? Because it is due to that rod. You have connected your earth there, right? No? So don't do that. Sometimes I have seen you will use two terminals only. Line and earth. Line and earth. You won't use neutral. No problem. Your appliance will work. In proper voltage, it will give you proper light if you have line and earth. But don't use that. Use three. Line, neutral, and three. Line, neutral, and earth. It is good. The question about it is, very first question I told you, we can connect line and earth. We can connect line and earth. We can connect, no problem. The question is, if you check voltage across neutral and earth, what voltage you should get? This is the question for interview, for fresher also, for experience also. The question is, what is the voltage we get across neutral terminal and earth terminal? What voltage we should get? Ideally 0 volt. Ideally 0 volt. But practically we get 2 or 3 volt. Practically we get 2 or 3 volt. If you are getting more than 4 or 5 volt, means your earth connection is not good. This is the way to check whether earth is proper or not. You check voltage across neutral and earth. You should not get voltage more than 4 volt or 5 volt. It means you have some problem. So practically we get 2 or 3 volt. You can answer like that, right? So line, neutral, and earth, all these three you use. And better we take one break for tea. We'll come back soon. We'll finish PLC programming. We will start PLC programming after that. Thank you.